Hello everyone, my name is Manny. I will explain to you the types of numbers in mathematics. The first basic set of numbers is labeled as n, and the name of it is natural numbers. And you could think about these numbers as numbers like 1, 2, 3, 4, and so on to infinity. But their characteristics are that they are positive, they don't include a zero, and they're whole. So that leads us to the second set of numbers, which is labeled as W and named as whole numbers. So whole numbers would be the same as natural numbers, but with the inclusion of zero. So 0 is included with whole numbers. We have 0, 1, 2, 3, 4, and so on. So the difference between whole numbers and natural numbers is that 0. Now, the next set of numbers is called integers. And its letter representation is just Z, big Z. Integers. Integers is the set of numbers that are composed of all whole numbers plus their images. So if we imagine that the zeros here and we have whole numbers here, and now if we imagine that all these numbers are reflected on this side with a minus sign, and so on to negative infinity. This set of numbers is called integers. So we see that whole numbers is a subset of integers, as well as natural numbers is also a set of integers, a subset in integers. Now the next set of numbers is actually called rational numbers, and rational numbers are represented by the letter Q. So rational numbers. From that word, if we think about rational in mathematics, rational means quotient. So the rational numbers are those numbers that could be represented as quotient of two numbers. For example, I'll give you an example. 0 is also a rational number because it could be expressed as a quotient over any real number, over any integer, let's say in this case. So it includes 0, 1, because 1 could be represented as that, all fractions, which are 1/2, 1/3, 1/4, and it extends to the number 2, which could be expressed as either 2 over 1 or 4 over 2 or 100 over 50 and so on. So it includes all of those numbers as well as their images on the negative side, negative 1/2, negative 1/3, and so on to negative infinity. So any numbers that could be represented as quotient of two integers are called rational numbers. But there is a restriction. The restriction is that the denominator cannot equal to 0. The denominator of this fraction cannot equal to 0. Okay? That's the only restriction for rational numbers. Now the next set of number is actually called irrational numbers. And now actually before irrational numbers, let's introduce real numbers. And real numbers are basically represented by the letter R for real numbers. And real numbers are defined as any numbers that could be represented as decimal numbers of finite or of infinite representation of decimal. So they include the 0, the 1, the 2, the 3, all of these integers, as well as it also includes the numbers like 1/3, which could be represented as decimal basically, which could be represented as 0.3333, an infinite representation. Also, it includes the number square root of 2, which could be represented as 1. I don't remember it exactly. So the square root of 2 is 1.4142135624, etc. So any number that could be represented as a decimal, infinite or terminating like the 1/2, which is 0.50. Okay, so the next set would be very logical, which is irrational numbers. Irrational numbers are defined as those numbers that are not rational. And what we mean by that, irrational numbers are actually represented by the letter I. Irrational numbers. So they're not rational. That means they cannot be represented as a quotient of two integers. So one example of irrational numbers is the number pi. Also, Euler number, e, or the natural number, e. Also, a square root of 2, or any square root of any number that's not a perfect square root. So these numbers are all irrational. So that's the set of irrational numbers. The next set of numbers is called imaginary numbers. And imaginary numbers, they don't have a letter to represent them because the letter I is for irrational. So I'll just write them as imaginary numbers. Imaginary numbers are numbers that could be represented, or numbers that are a real number multiplied by the square root of -1. So we could take all real numbers and multiply them by the square root of -1, and they will form imaginary numbers. So square root of 2, square root of 1, or -1. And square root of -1 is in imaginary numbers is called I. So any number that has an I next to it, or multiplied by I, is called an imaginary number. Now we come to the real category that includes imaginary numbers, which is called complex numbers. And complex numbers are represented by the letter C, and complex numbers are those numbers that could be represented or written in the form of a plus bi. Basically, these numbers will have a part imaginary, or part real, sorry, and the other part of it is imaginary, and they're added with each other. Or the a or the b could be 0. So they include all real numbers and they include all imaginary numbers. These are called complex numbers. Now the next set, just for curiosity, will include a set of numbers called hypercomplex numbers. And hypercomplex numbers include, but not limited to, a set called quaternions. And quaternions, there's actually an N here. Quaternions are those numbers that could be represented as a sum of, you see how we have in complex numbers part real, part imaginary. Now it extends this concept to include a set of numbers that could be represented as a real, a complex, plus another complex number, plus another complex number. And the identity for this set of numbers is actually as follows. This identity would be I squared is equal to j squared is equal to k squared is equal to j I j k, and this is all equal to -1. This is the identity of all of these numbers, and it looks amazing. So this was the lesson of the types of numbers that you would encounter when taking, a math course. Basically, these are all up to The complex numbers are more likely that you will see them, but in your maybe high school, college, up to getting your master's, getting your bachelor's, and quaternions. Maybe you'll see them in your graduate studies if you specialize in some type of field that uses them. Otherwise, they're not directly used. They're used more in three-dimensional rotations and robotics. They're used a lot in like Euler rotations and so on. Um, so this is it for the types of numbers. I hope you benefited of this video, and I hope you good luck with all of your studies. Thank you for watching.